Hi, I'm Sophie,
I'm Lou.
and today you're going to learn how to use the chain rule.
And the power rule.
Go ahead.
Okay, so in this video we are going to explain how to use the power rule. So to differentiate the power function, you have f of x equals x to the n, and you're going to multiply by the original exponent n and reduce the exponent by 1 to get the new exponent. So a written way of explaining that would be f of x equals x to the n, then f of prime x equals nx to the n minus 1, whereas n is the constant. So an example problem of this would be f of x equals 5x to the fourth, and what you would do is you would multiply the constant exponent 4 times the coefficient, which is 5, and you would get 20, and then you would subtract 1 from the constant, which is the exponent 4, to get 3. So we have f of prime x equals 20x cubed. And if there was no coefficient in front of the x, we would assume that it would be 1 because there's 1x. So it would be 1x to the fourth. And you would multiply 4 times 1, which equals 4. Subtract 1 from 4, x cubed. And you would get f of prime x equals 4x cubed.
Okay, so this is another example of a problem that we could use the power rule on. So the problem is 3x minus 4, all that squared. So I already took the liberty of writing it out in its expanded form, and now we're going to take the derivative of 9x squared minus 24x plus 16. So, like the power rule says, we're going to take this exponent and multiply it by our coefficient of 9. So we'll give us 18x, and we're going to subtract the 2 by 1, so that'll be 18x to the first. Then we're going to take the derivative of this. There's a little imaginary 1 there, and we're going to multiply that 1 by that 24, giving us a negative 24. We're going to subtract that exponent by 1, and x to the 0 is always going to be 1, so that x turns into a 1. Negative 24 times 1 is still negative 24, and as we already learned in calculus, the derivative of a constant is always 0, so we could add a plus 0 for the 16, but we don't really need to in this case. So the derivative of our final function is 18x to the first minus 24.
Okay, so now we are going to explain how to use the chain rule. So verbally, the chain rule says to take the derivative of the outside function while the inside function stays the same. Then multiply the result by the derivative of the inside function. So this is the shorthand of what I just said. And now we're going to do an example. Our example is f of x equals cosine 3 to the x. So here, cosine is the outside function, while 3x is the inside function. So we're going to take the derivative of cosine, which equals negative sine, and then we keep the inside function the same. But our next step is to take the derivative of the inside function, and as we know from the power rule, we have our exponent is equal to 1, so we do 1 times 3, which would just be 3. So now we can simplify this into f of prime x equals 3 times negative sine, negative 3 sine, 3x.
Okay, so our next example problem for the chain rule is f of x equals cosine of 7x, all of that raised to the fourth power. So the first thing I did is I differentiated which was the outside, middle, and inside functions. Outside is colored in red, middle in black, and inside in green. I first took the power rule on the exponent, moved it in front, subtracted that by 1, and kept my inside exactly the same. Next step, I took the derivative of the middle function, which was cosine. The derivative of cosine is negative sine. I multiplied it by this function over here, and I kept the inside, the 7x, exactly the same. Last step, I took the derivative of the very inside of the function, the 7x, using the power rule. The derivative of 7x is 7, so I just multiplied that by a 7. So now, when we combine all of our terms, f prime of x will equal negative 28 cosine 7x to the third times sine of 7x. That's your answer. Okay, so we chose to do the chain rule and the power rule for this video project because we both felt like those topics were things that we struggled to understand in class, and working on them outside of class on this video project made it seem like they're actually not that difficult if you practice.
We also have two tests coming up this week, so we thought it was a great way to practice and to become even more familiar with the chain rule and power rule.